Hi everyone. So today we're going to go over the paper part of the Unit 1 test, which was um, the honors topics. All right. So the first part, shade the Venn diagram to represent each expression. So you had to remember that this is the intersection, and the intersection is they um, where they both have the same numbers, what they share in common. So the intersection is just what they have in common. That's the middle part there. All right. The union is all of it. It's everything. It's joining everything that's in A with everything that's in B. So you would list everything in both of them. And then this is kind of doubling them. This is the intersection of A and B. So the intersection of A and B does include both of these. But then when we take that and we need the intersection with C, it doesn't include this part. So those of you that shaded in just this middle section, that one was correct. All right, so we have, how many subsets does a set with 6 elements have? All right, so this was the problem that it's kind of the formula that tells us how many subsets any set has. So if I have, this was the example we did in class. If it was this set and we started to list all the subsets, well, the subsets are S and L and E, right? D, and then we could do 2 of the letters. So SL. Or we could have none of the letters. The empty set is a subset of all integers. Yes. So that second question should be, that answer there should be yes. It is a subset of every set of numbers. Then we could have 3 letters, right? So this was the formula, 2 to the however many are in this set. This one happens to have 6 in this question. So it's 2 to the 6th power. And 2 to the 6th power is 2 times 2 times 2 times 2 times 2 times 2, which is 64. So all you needed there was 64 to get it correct. What is n of f if f equals this? So this is just asking for the number of elements in the set. That's it. A, B, C, D, and E. That's 5. 1, 2, 3, 4, 5. That's how many elements are in the set. So this would be 5 if that was what F is. It's like the number of elements in the set. All right. Okay. All right. Density property. So this one is asking what is between two numbers. What rational number is halfway between 4/5 and 3/4? So there was 2 different strategies we learned about in class. I thought the easiest one was when we add those 2 up and divide by 2. Whatever this answer is, we're going to divide it by 2. It's just like saying what's in between 40 and 50. What's halfway between 40 and 50? Well, if you do 40 plus 50, that's 90. And if you do 90 divided by 2, that gives you 45. And that's what's halfway between these. So we're doing the same thing. We're just using fractions. You have the Desmos calculator for this one. So you could have just put this into Desmos and turned it back into a fraction. But remember, 5 and 4, the lowest common multiple is 20. 5 times 4, 4 times 4 is 16. 4 times 5, 3 times 5 is 15. So I'm just making them have common denominators. So 31 twentieths. And now I need to divide that by 2. And if you remember from elementary school, dividing by 2 is the same as multiplying by a half. We flip, we multiply by the reciprocal. So 31 times 1 is 31. 20 times 2 is 40. This was the correct answer. This fraction is halfway between 4/5 and 3/4. Now we're going to take that answer and find what it is halfway between 3/4 and that number. So 31 40ths plus 3/4. Lowest common multiple is 40. So I'm going to change this to a 40, 4 times 10 and 3 times 10. and add these two fractions up. So 31/40 plus 30/40 is 61/40. And now I'm going to divide that answer by 2. And 61/40 divided by 2 is the same as multiplying by a half. So this answer is 61/80. All right, now I'm going to take 61/80 and I'm going to add it to the 3/4. So 61/80 plus 3/4, and I'm going to divide that answer by 2. I'm going to turn 3/4 into 80. So 4 times 20, 3 times 20 is 60. So 61/80 plus 60/80 is 121/80 divided by 2, which is really multiplying by a half, gives me 121. 80 times 2 over 160. So those are our 3 answers for these density questions. You add up the fractions and divide by 2. I did want to see all this work, or at least what you were putting in the calculator, written out here for full credit. All right, on to the next. Simplify the following radicals does not mean put this square root of 75 into Desmos and put the decimal. Simplifying it, remember, is factoring it out to its simplest form, not as a decimal. So its simplest form, there was 2 ways I taught you this. The first way was to list the perfect squares: 1, 4, 9, 16, 25, 36, 49, and see if any of these were factors of 75. And I know, looking at this list, that 25 is a factor of 75. So I broke it up into 25 times 3. This was the lesson I taught you the first way. Then I can pull out the square root of 25 is 5. So I can say that answer, I can simplify that, but the square root of 3 can't be simplified anymore. The square root of 3 is a decimal. Right? It's not an integer that I can say that that's equal to, so I'm done. The new way, I said, was to just list prime numbers and prime factor 75. So prime factorization way would be, the prime factors are 2, 3, 5, 7, 11, 13, and I would divide these by each of these and just prime factor this. So I'm going to do, I know that 5 goes into 75 times what? 5 goes into 75. 1, why am I drawing a blank? 5, 15. Okay. So 5 times 15 is 75. Just do that math on Desmos. 5 is a prime number, so I still need to factor 15 to its prime factorization, which is 3 times 5. So this way, you're finding the prime numbers that repeat, and that is what I can pull on the outside because they're repeating. So it's 5 times 5, which is 25, right? And then the square root of 3 gets left on the inside because I can't, it's not a perfect square, right? I can't pull out that number. So this 75, the square root of 75, is the same thing as the square root of 5 times 3 times 5. It's basically another way of doing this, except you didn't go straight to the 25, but we still get the same answer. All right, let's look at 108. So for 108, I'm going to look at the prime factorization because I know that I can do 2 because I don't know if any of those work, but I do know that 2 works. 2 times 54. All right, 2 is a prime number, and I know that I can still do 2 again because that's an even number, right? And 2 times 27. And 2 is prime, so I'm done there. That 2 is prime, so I'm done there. This will break up into 3 times 9. All right, 2 prime. 2 is prime, 3 is prime, and 9 breaks up into 3 times 3. This is the prime factorization of 108. So wherever there's a repeat, such as those 2, that gets pulled to the outside because the square root of 4 is 2. And these get pulled to the outside because the square root of 9 is 3. So I'm basically putting those on the outside, and that square root of 3 gets left on the inside because it's not a perfect square. Then I simplify this. 2 times 3 is 6, square roots of 3. 242, I'm going to do the prime factorization way again. And I'm going to, because I know that 2 goes into it, but I'm not sure about any of those other ones. So prime factorization, 2 times 121, and 2's prime. Now this one is a little bit harder, but the next prime is 11, and it's 11 times 11. So my groupings, what is a perfect square? These two, because 11 times 11 is 121. So that goes on the outside, square roots of 2 left on the inside. All right. Let's go to the back of your paper part. So the Venn diagram, you had to look at all of these parts to fill them in to the Venn diagram. So take a look at these statements, and you might have to go all the way down to the last statement before you can start filling in numbers. All right, so I'm going to focus on the last 2 statements first. 6 liked none and 4 liked all 3. So I'm going to have a 6 on the outside. So 6 liked none and 4 liked all 3. So I know that goes in the middle. And then if I'm looking at my other statements, I'm going to go backwards kind of. So this one says 20 liked Bugs Bunny and Homer. 20 liked Bugs Bunny and Homer. So I'm going to do 20. 20 likes Bugs Bunny and Homer, which is right here, B and C, which means that in this part, so I hope these colors don't confuse you, but in this part, it has to add up to 20. But 4 of them are already in this section, so I know that when I subtract, this section is 16. All right. The next statement up was 17 liked SpongeBob and Homer. 17 liked SpongeBob and Homer. So SpongeBob and Homer is this part over here, and 17 liked them. So 4 of them are already there. 17 minus 4 is 13. And that's how I figure out this part that only liked SpongeBob and Bugs Bunny. Or SpongeBob and Homer, sorry. All right, the next statement up was, I'll show you, was 9 liked SpongeBob and Bugs Bunny. 9 liked SpongeBob and Bugs Bunny. So now I'm focusing on this part, SpongeBob and Bugs Bunny, and it's a 9. So the whole thing has to add up to 9, and 4 of them are already here, so 9 minus 4, 5. All right, up to the next statement. 39 liked Homer. So this is what the statement before says. 39 liked Homer. Okay, so 39 for this whole circle. This whole circle has to be 39. But right now, the 4 and the 16 equal 20, and 20 plus 13 is 33. So there's already 33 of those 39 posted. So I'm only going to put a 6 here because 39 minus those that are already taken, that leaves me the 6 left over. All right, and then 25 liked Bugs Bunny. So 25, pick a different color, liked Bugs Bunny, which is B. So that means this whole circle needs to add up to 25. And right now, it adds up to 25. So nobody only liked Bugs Bunny. That gets a 0. And then our last statement, 22 liked SpongeBob. So the whole circle for SpongeBob has to add up to 22. I've done purple. So this whole circle has to add up to 22. And let's see what it already adds up to. 13 plus 4 is 17 plus 5 is 22. So again, nobody liked only SpongeBob. Now that I have my numbers here, I can answer these questions. How many students liked SpongeBob only? SpongeBob only is B, but it's only this part, right? That's the only. So that's going to be 0. There were no students that liked SpongeBob only. Oh, wait, SpongeBob was A, sorry. Over here, A. All right, how many students liked Homer only? Homer is C, so I'm looking down in this part, and there was 6 that only liked Homer. How many did not like Bugs Bunny? So a lot of you got this one wrong because you forgot about this 6 over here. Did not like Bugs Bunny is everything outside of the Bugs Bunny circle. So there's a 13, a 6, a 0, and a 6. So for this one, you had to do 13 plus 6 plus the 6 that didn't like anybody. And I think a lot of you left that one off. So this answer was 25. I think a lot of you got 19. How many students like neither Homer nor Bugs Bunny? Neither Homer nor Bugs Bunny. So nothing in this circle and nothing in this circle. So it can't be any of those numbers, and it can't be any of those numbers, which leaves me just the 0 over here and the 6. A lot of you forgot about that 6 again. That was nobody. And then the last question says how many total students were interviewed. So this is where we have to add up all these numbers in here because they all represent a different part, right? So 6 here, then all of these numbers in here for Homer. So that's 29, 39, right? 16 plus 13, 29 plus 10, 39, and then 39 plus 11 is 50. So there was 50 total students. Hope that helped. Let me know if you have any questions before you do the retake. Thanks, guys.